Hello students, welcome to chemistry class. In the last class we have studied about the types of chemical bonds, right? So mainly there are two types that is to be discussed in the previous class. So one is covalent bond and second one is ionic bond. So ionic bond is to be formed by the cations and anions, right? So between the cations and anions there is a certain electrostatic force of attraction. So that electrostatic force of attraction between the cations and anions is to be called as ionic bond. And also we have studied about the what are the factors which are favorable for the formation of ionic bond. And then we have studied about the covalent bond. So that covalent bond is to be formed by the mutual sharing of valence electrons present in the atoms. That is, covalent bond is to be formed by the mutual sharing of valence electrons that is to be present in the atoms, right? So in that we have studied about the formation of hydrogen molecule. So between the hydrogen atoms there is one pair of electron. So that pair of electrons indicates the between the two hydrogen atoms it contains one hydrogen bond, right? So between the two hydrogen atoms it contains one bond. So this bond is to be called as single bond, right? So this single bond is to be represented by using a single horizontal line. Next let us see the formation of double bonds, right? So the double bonds are generally formed by the mutual sharing of two pair of electrons. That is, a covalent bond is formed by the mutual sharing of two pair of electrons. So if the two pair of electrons are mutual sharing, there is one covalent bond. That bond is generally to be called as double covalent bond. Simply that bond is to be called as a double bond. For example, let us take carbon dioxide molecule. So the formula for the carbon dioxide is CO2. That is, the molecule contains one carbon atom and two oxygen atoms, right? So the Lewis structure of this carbon dioxide molecule is to be written as, that is C and two oxygen atoms, and between the two oxygen atoms, that is the two electrons of the carbon and mutual sharing with the two electrons of one oxygen atom, and the remaining two valence electrons of the carbon atom and mutual sharing with the two electrons of the oxygen atom. And this oxygen also contains two more pair of electrons, and this oxygen also contains two more pair of electrons. But the covalent bond is to be formed by the two pair of electrons. So the two pair of electrons are generally to be called as double bonds. And all the atoms in this molecule has 8 electrons, right? Oxygen 2, 4, 6, 8 electrons, and in this oxygen atom, that is 2, 4, 6, 8 electrons, and this carbon also contains 8 electrons, right? 2, 4, 6 and 2, that is totally there are 8 electrons. So in this Lewis structure of the carbon dioxide, all the atoms contains 8 electrons. So the bond between the carbon and oxygen is generally to be called as double bond. So these double bonds are represented by two small horizontal lines. So these two small horizontal lines indicates the presence of two pair of electrons between the atoms, right? So if the two pair of electrons present between the two atoms, that pair of electrons are generally to be called as double bond. So it is to be called as double bond. So Double bonds are generally to be formed by the mutual sharing of two pair of electrons. So very, very important. Single bond is to be formed by the mutual sharing of one pair of electrons. That one pair of electron means that contains two electrons. That is one electron to be transferred from one atom and one electron to be transferred from the another atom. For example, let us take hydrogen molecule. So one electron is from this hydrogen and one electron from this hydrogen, right? So on mutual sharing of these two electrons, one bond is to be formed. That is to be called as single covalent bond. Like that, the double covalent bonds are to be formed by the mutual sharing of two pair of electrons. That is, from oxygen atoms 2 electrons and from carbon atoms 2 electrons. Totally it has 4 electrons, right? That 4 electrons is to be called as two pairs of electrons. And let us take one more molecule, that is ethene. Ethene, that is the formula for ethene is C2 and it is H4. So between the two carbon atoms, that is the two carbon atoms in the ethene molecule are to be joined by two bonds. So the two bonds are to be called as double bonds, right? So hydrogen and carbon atoms linked by one pair of electrons, and the carbon atoms are to be linked through the two pair of electrons. That is to be called as double bond. So between the carbon atoms there is an double bonds, and between the carbon and hydrogen it contains only one pair of electrons, right? So the double bonds are to be formed by the mutual sharing of two pair of electrons. Two pair of electrons. And let us see the formation of triple bonds, that is triple covalent bond. So the name itself indicates that the covalent bonds are generally to be formed by the mutual sharing of three pair of electrons, right? So if the three pair of electrons and mutual sharing, so force of attraction is to be formed. That force of attraction is to be called as triple covalent bond. Simply it is to be called as a triple bond. Let us take an example, that is nitrogen molecule, N2 molecule. So this N2 molecule is to be formed by the two nitrogen atoms, right? So between the two nitrogen atoms there is an certain force of attraction. So that force of attraction is to be arised by the mutual sharing of three pair of electrons. That is, between the nitrogen atoms there is an three pair of electrons. So such three pair of electrons are simply represented by using a simple horizontal lines or some small horizontal lines. That small horizontal lines are to be called as triple bonds. So that is, if the three pair of electrons and mutual sharing, so the obtained bonds are generally to be called as triple covalent bonds. And let us take one more example, that is ethyne molecule. Ethyne. So this ethyne, that is the formula is C2H2. That is two carbon atoms are joined by three pair of electrons, and the carbon and hydrogen is to be joined by a single pair of electron. So between the carbon atoms there is an three pair of electrons. So such three pair of electrons are to be called as triple bonds. So it is to be called as triple covalent bond. Triple covalent bond. So the triple covalent bond is to be formed by the mutual sharing of three pair of electrons, right? So single bond is to be formed by the mutual sharing of one pair of electrons, and double bonds are to be formed by the mutual sharing of two pair of electrons, and triple bonds are formed by the mutual sharing of three pair of electrons. Next, let us see what are the factors which are favorable for the formation of covalent bond. So mainly there are three factors which are favorable for the formation of covalent bond. That is, first one, the combining atoms must have very high ionization enthalpy and very high electron affinity. So let us see what is meant by ionization enthalpy and electron affinity. So in the previous class already we have studied about the ionization enthalpy and electron affinity in the factors favorable for the formation of ionic bond, right? For example, let us consider, so this is nucleus, so and it is first energy level and second energy level and it is third energy level. So electrons to be filled in the first energy level, that is to be called as 1s orbital, and it is second energy level, so the second energy level contains 2s as well as 2p orbitals, and this third energy level contains 3s, 3p and 3d orbitals, right? So ionization enthalpy is nothing but the amount of energy required to remove an electron present in the outermost orbital. For example, let us say these are the electrons to be present in the outermost orbital. So in order to remove one electron from the valence orbital, it requires energy, right? So amount of energy required to remove an electron from the valence shell of neutral atom. Such energies are generally to be called as ionization energy, right? So in order to form the covalent bond, the combining atoms must have very high ionization enthalpy. If it has very high ionization enthalpy, it does not readily converted into ions, but it is opposite to the ionic bond, right? So for the formation of ionic bond, ionization energy must be low for the metals, but in the case of the covalent bonds, the ionization energy of the combining elements must be very high, and that electron affinity also to be high. So amount of energy change when an electron is added to the atom, so that amount of energy change is to be called as electron affinity, or it is also to be defined as amount of energy removed when an electron is added to the atom. For example, let us say we have one extra electron, so that electron is to be added to the valence shell of the neutral atom. So in that case, certain amount of energy is to be released. So how much amount of energy is released when an electron is added to the outermost orbital? So that energy change is generally to be called as electron affinity. Electron affinity. So ionization enthalpy is nothing but amount of energy, ionization enthalpy. So ionization enthalpy is nothing but amount of energy required to remove the electron. So the amount of energy required to remove the electron is to be called as ionization enthalpy. So the amount of energy changed when an electron is added to the valence shell, that is to be called as electron affinity. So both the ionization enthalpy as well as the electron affinity for the combining atoms must be very high. So generally the halogens has very high electron affinity values. So that halogens has very high electron affinity values. And the next point, that is electronegativities. So the electronegativity is nothing but the capacity or ability of an atom to attract the electron, right? So electronegativity is nothing but it is an ability or it is a capacity of that atom to attract the electron. So that affinity is generally to be called as electronegativities. So the combining elements must have very high electronegativities. That is, the electronegativity of the two combining atoms is very, very high. And the difference between the electronegativities between the two combining atoms should be minimum. That is, the electronegativity of that atom is to be very high. For example, let us take chlorine molecule, right? So the chlorine molecule has two chlorine atoms. So the electronegativity of the chlorine is very high, right? So the electronegativity of the chlorine is very high, and the difference between the electronegativities of the two combining atoms, here the combining atoms are two chlorine atoms, right? So the electronegativity difference is 0. So the electronegativity difference between the two atoms should be very, very less. So in that case only covalent bonds are generally formed. And the next point, that is high nuclear charge and small atomic size of the combining elements. So what is this nuclear charge? So it is a force of attraction between the electrons present in the outermost orbital with the nucleus. That is, the affinity between the electrons present in the outermost orbital with the positive part present in the nucleus. So generally electrons has negative charge, right? Opposite charges are attracts with each other. So that affinity is simply to be called as nuclear charge. So greater the nuclear charge, size of the atoms decreases. That is first energy level, second energy level, and third energy level. So if the attraction between the electrons and the positive part is present in the nucleus is more, in that case the size of the atom is decreases, right? So if the size atom is decreases, that atoms are favorable for the formation of covalent bond. That is, these are the three factors which are responsible for the or favored for the formation of covalent bond. One is the combining atoms must have high ionization enthalpy and high electron affinity values, and also it has very high electronegativities, but the difference between the two combining atoms must be less, and high nuclear charge and small atomic size. So these are the factors which are favored for the formation of covalent bond. Next, let us see how to write the Lewis dot structures for the molecules. That is, the Lewis dot structure of carbon monoxide molecule. So in order to write the carbon monoxide Lewis dot structure, we have to follow some important steps. That is, first we have to count the total number of electrons present in the carbon as well as in the oxygen atoms. Let us solve step by step. That is, first one, count the total number of valence electrons present in the carbon as well as in the oxygen atom. So the electronic configuration of the carbon, that is, the atomic number for the carbon is 6. So electronic configuration is 1s2, 2s2, and it is 2p2. 2, 4, 6 electrons, right? So this electronic configuration is also to be represented as, that is, helium. So why it is helium? Because 1s2 is the configuration of helium. So helium, and it is 2s2 and 2p2. So this outermost orbital contains 4 electrons, right? So the valence electrons of carbon, that is equal to 4. And let us take an oxygen atom. So atomic number for oxygen is 8 and its configuration 1s2, 2s2, and it is 2p4. 4, 5, 6, 7, 8. And this oxygen is also written as, that is helium, and it is 2s2, so it is 2p4. That is the electronic configuration of oxygen. So the valence electrons, that is the number of electrons present in the outermost orbital, that is 4 plus 2. Finally, it has 6 valence electrons. So first step is, we have to count what is the total number of valence electrons present in both the carbon as well as in the oxygen. So the total number of valence electrons present in oxygen and carbon, that is equal to number of valence electrons in the oxygen is 6 plus number of valence electrons in the carbon, that is equal to 4. So it has 10 valence electrons, right? Next step, so write the skeleton structure of the molecule. So skeleton structure is nothing but the representation of the different elements present in the molecule. So this molecule, that is carbon monoxide molecule, contains two types of elements. So one is carbon, another one is oxygen. So the representation of the different elements present in the molecule is to be called as skeleton structure. And next, draw a pair of electrons or a single bond between the atoms. So here the atoms are carbon and oxygen. So we have to write one pair of electrons between the atoms and complete the remaining octet of the oxygen atom. That is, we have totally 10 valence electrons. That is 10 valence electrons from both the carbon as well as from the oxygen. So we have to distribute these 10 electrons to the carbon and oxygen. So in order to distribute these electrons, first we have to write one pair of electrons between the carbon and oxygen, and then the remaining electrons transfer to the carbon. So first write octet electrons on the oxygen atom, that is 2 and 4, 5, 6, 7, 8. And then we have 2 more electrons. That electrons is to be transferred to the carbon. So here only oxygen has 8 electrons, right? So oxygen only contains 8 electrons, but this carbon contains only 4 electrons, right? So this is not actual Lewis dot structure of the carbon monoxide. So in the Lewis dot structure, all the atoms must contain 8 electrons. To satisfy the octet rule, arrange the multiple bonds between the carbon and oxygen. That is, multiple bonds are to be used. So one pair is to be shifted, that is 2, 4, 6, and one more pair of electrons is to be shifted towards the or between the carbon and oxygen. So totally it has 3 pair of electrons between the carbon and oxygen, right? And this oxygen contains one more pair, and this carbon also contains one more pair. So totally all the atoms gets 8 electrons. That is, this carbon contains 8 electrons and this oxygen also contains 8 electrons. So this is the correct Lewis dot structure of the carbon monoxide molecule, and this molecule is also to be written as, that is C triple bond O, and one pair of electrons on the oxygen as well as one pair of electrons on the carbon. So these are the steps to be used to write the Lewis dot structures for the molecules. And next, let us take one more example, that is the Lewis dot structure of nitrate ion, that is to be called as NO2 minus. So same steps to be used to write the Lewis dot structures for the molecules. That is, first we have to count the total number of valence electrons, and then we have to write the skeleton structure, and then draw a bond, that is distribute the valence electrons to the all atoms. First, count the total number of valence electrons. So the electronic configuration for the nitrogen, that is atomic number for nitrogen is 7 and its electronic configuration 1s2, 2s2 and it is 2p3. So this outermost orbital contains 5 valence electrons, that is valence electrons is equal to 5. And in the case of oxygen, so atomic number for oxygen is 8, so its configuration 1s2, 2s2, 2p4. So the number of valence electrons in the oxygen atom is equal to 4 plus 2, 6, right? So there are 5 electrons in the nitrogen and 6 electrons in the oxygen. So total number of valence electrons present in that molecule, that is total number of valence electrons is equal to 5 plus 6 into, there are 2 oxygen atoms in the molecule, it is 2 plus, there is one negative charge in the nitrate ion, right? So that negative charge indicates the presence of an extra electron. So that number of electrons is to be added to the total valence electrons. That is very, very important. If there is a negative charge, that number of electrons to be added to the total number of valence electrons. If it has positive charge, that number of electrons is to be removed from the total valence electrons. So 5 plus 6 2s are 12 plus 1. So total number of valence electrons is 18 valence electrons, right? So the total number of valence electrons in the NO2 molecule is 18. So write the skeletal structure. So the skeletal structure for the nitrogen monoxide, so N, O and it is O, that is it contains 3 atoms, that is one is nitrogen and 2 oxygen atoms. And next, draw a single bond, that is one shared pair of electrons between the atoms, that is 1 pair and 1 pair. So totally out of 18, 4 electrons to be filled between the atoms. So 2 plus 2 4, 5 6, 7 8, 9 10, 11 12, 13 14, 15 16, 17 18. That is, out of 18 electrons, 1 pair of electrons is to be written between the 2 atoms, and the remaining electrons are to be distributed to the end atoms. That is, end atoms in this molecule is oxygen atoms. So first we have to write 1 pair of electrons between the atoms, then the remaining electrons are to be distributed to the oxygen atoms, and the remaining electrons to be written on the nitrogen atom. So out of 18 electrons, so 1 pair of electrons is to be written between the 2 atoms, that is between the nitrogen and oxygen atoms, and the remaining electrons are to be distributed first to the end atoms, that is to the oxygen atoms, to obey the octet. And let us see how many electrons are present in the oxygen atoms and in the nitrogen. So this nitrogen contains only 2, 4, 6 electrons, right? But oxygen atoms contains 8 electrons. It indicates that there is an certain multiple bonds between the atoms, right? So one pair of electrons are to be shifted to the or towards the nitrogen atom. So the Lewis structure for this molecule is to be written as, that is, two pair of electrons between the oxygen atoms and the remaining only 4 pairs. That is, this oxygen contains 2, 4, 6, 8 electrons, and this oxygen also contains 8 electrons, and this nitrogen contains 2, 4, 6, 8 electrons. Totally all the atoms has 8 electrons, and this molecule is also to be written as, that is, NOO. That is, if these two pair of electrons are to be present between the nitrogen and oxygen, so in that case there is an multiple bond between these two atoms, that is between the nitrogen and oxygen, and there is an one pair of electrons. So on the remaining electrons, so 2, 4, 6 and 2. So this oxygen contains 2, 4, 6, 8 electrons, and this oxygen also contains 8 electrons, and this nitrogen also contains 8 electrons, right? So the molecule is to be written as, that is, NO and the remaining 3 pair of electrons, and it is double bond O and 2 pair of electrons, and there is an one negative charge on the molecule, right? And this NO2 is to be written as, that is, N double bond O, and this oxygen contains only 2 pairs and single bond O, and it contains 3 pair of electrons and negative charge. So this is to be called as the Lewis dot structure of the NO2 molecule. So very simple and important concept for the competitive as well as for the theory exams. So in the theory exams they may ask, write the Lewis dot structure for the any molecule. So in that case, count the total number of valence electrons, then write the skeletal structure, and then distribute electrons to the atoms. In the distribution of the electrons, first write one pair of electrons between the atoms, then the remaining electrons is to be distributed to the end atoms. If you have any more extra electrons with you, in that case only it is to be distributed to the central atoms. So if all the atoms does not follows the octet, in that case it is to be satisfied by writing the multiple bonds between the atoms. So these are the steps to be used to write the Lewis dot structures. And next let us see the formal charge. So what is meant by formal charge? So here we have studied about the Lewis dot structure of the NO2 molecule, right? So there is an one negative charge on the molecule, right? NO2 is to be written as NO2 minus. So the net charge is possessed by the ion as a whole, not by a single or particular atom. That is, this negative charge is for the entire molecule and not for a particular atom. That is, in the Lewis dot structures of the polyatomic ions, so the net charge is possessed by an ion as a whole and not by a particular atom. So in a molecule, the constituent atoms do not carry any charge. That is, for example, let us take in the nitrate molecule. So in the nitrate molecule, this nitrogen atom and oxygen atom does not carry any charge. However, it is useful to assign a formal charge on the each atom. So formal charge is defined as it is the difference between the number of valence electrons of that free atom and the number of electrons assigned to that of an Lewis structure. So it is the difference between the number of valence electrons of that free atom and the number of electrons assigned to that atom in the Lewis structure. So that is to be expressed as, that is, formal charge is equal to total number of valence electrons of the free atom or in the free atom minus total number of non-bonding or simply it is to be called as lone pair electrons. So lone pair is nothing but the electrons which are not involved in the bonding, and that is minus of half of the total number of bonding, that is shared electrons. So the formal charge is equal to the total number of valence electrons of the free atom minus total number of non-bonding electrons minus half of the total number of bonding electrons. Let us see how to calculate the formal charge of the atoms present in the molecule. For example, let us take ozone molecule. That is, the formula for the ozone is O3. Let us calculate the formal charge of all the atoms present in the ozone molecule. So here ozone molecule does not carry any charge. So that is, it is a neutral molecule. However, the charge of the particular atoms present in the molecule is to be expressed as formal charge. So in order to calculate the formal charge, first we have to write the Lewis dot structure of the molecule. So to write the Lewis dot structure, we have to know what is the total number of valence electrons. That is, oxygen has atomic number 8, so its configuration 1s2, 2s2, and it is 2p4. So the total number of valence electrons are 6. That is, total number of valence electrons is equal to 6 into number of atoms. So that molecule contains 3 oxygen atoms. So 6 3s are 18 electrons. So distribute this 18 electrons to the 3 oxygen atoms, and by writing one pair of electrons between the atoms, and the remaining electrons to be distributed through the oxygens. That is 2, 4, 6, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18. And let us count the total number of electrons present on the each atom. So this oxygen is to be marked as 1, and it is to be 2, and it is to be 3. So second oxygen, third oxygen contains 8 electrons, but first oxygen contains only 6 electrons. So that indicates that the multiple bonds to be present between the atoms. So let us shift one pair of electrons to the first carbon, first oxygen. So that is double bond O, and it is double bond O. So this oxygen contains one pair, and it contains 3 pairs, and it contains only 2 pairs. So it is first, second, and third oxygen. That is, the Lewis dot structure of the ozone molecule is like this. So let us calculate the formal charge of the first oxygen atom. Formal charge of oxygen marked as 1. That is equal to, so the formula to calculate the formal charge is the number of valence electrons of the free atom minus total number of lone pair of electrons minus half of the total number of bonding electrons. So the number of valence electrons of the free oxygen atom, that is number of valence electrons are 6 minus the number of lone pair of electrons. So this unshared pair of electrons are generally to be called as lone pair. So it is to be called as lone pair of electrons. So this lone pair of electrons, that is, it contains 2 electrons, right? One pair is nothing but 2 electrons. So it contains 2 electrons minus half of the bond pair of electrons or shared electrons. So these electrons present between the atoms to be generally to be called as shared pair of electrons. So this oxygen contains 2, 4, 6. That is, one bond indicates the presence of 2 electrons. So 2, 4, 6. That is 6 electrons. That is equal to plus 1. And let us calculate the formal charge of the oxygen marked as 2. That is equal to number of valence electrons 6 minus number of lone pair of electrons, that is 2 plus 2, 4 minus half of the bond pair of electrons. So it contains only 2 bonds, that is 4 electrons. On simplification it gives 0. And then let us calculate the formal charge of oxygen marked as 3. That is 6 number of valence electrons minus number of lone pair of electrons, that is 2, 4, 6 minus half of the bond pair of electrons. So it contains only one bond, that is 2. That is equal to 6 minus 6 minus half of 2. That is equal to minus 1. Right? So the first oxygen has charge, that is plus 1, and second oxygen has charge 0, and third oxygen is minus 1. Right? So the charge of the particular atom in a molecule is to be called as formal charge. That formal charge is to be calculated by using the formula, that is total number of valence electrons in the free atom minus total number of non-bonding electrons minus half of the total number of bonding electrons. And next let us see what is the advantage of the formal charge. So by calculating the formal charge of the atoms present in the molecule, so we can identify the lowest energy structure from a number of possible Lewis structures. So in the Lewis structures we can identify the lowest energy structure. So lower the energy of the Lewis dot structure, greater will be the stability of the molecule. That is, lowest energy structure is the one with the smallest formal charge on the atoms. So these are the two applications or advantages of the formal charge.